let's get going. So what's the goal of this whole chapter? There's two main goals. What are they? Put it on the board yesterday.
Find the derivative of any function.
Be able to find the derivative of any function. Anything you can imagine, we can find the derivative. Because every function has a derivative. Okay, what was the other point? Harry? Understand what the derivative is. Okay? You know, intimately know the derivative. And then we're going to be doing applications of it in the next chapter. All right, so yesterday we came up with a couple of rules. What's fun about this is you wrote the rule, you came up with the rules, I didn't. So here's what I think we got. I'm going to write a different notation. Okay, using different notation. So you got to know all these different notations. Okay, and so let me show you what I got. If I have a constant, okay, if I've got a constant, and I want to find the derivative of it, okay, I can write this notation. I can say the derivative of k with respect to the x variable is equal to. Now it's going to seem weird, this notation, until you get used to it. Okay, so don't worry about that, it'll come. The derivative, this is how this first d says the derivative of this function. Okay? This dx means with respect to the x variable. And in this case, it's a constant, so there is no x in it. And so what is the derivative of the constant? It was the first rule that we had. 0. Because the slope is always 0. Okay, so I'm writing in a different notation. The second one that we said we had was kx. Okay, so I'm going to write this in this notation. I'm going to say the derivative. Okay, this means the derivative of kx with respect to x. Okay, now this has an x in it. What is the derivative of kx? K. It's, if you have a line, the derivative is whatever the slope of the line is. Okay. All right. Then this one we didn't write on the board. The derivative with respect to x of what if you just had x to the nth, where n can be any number. This means what is the derivative of x to the nth with respect to x? What do you say? X, absolutely. So it's n times x to the n minus 1 power. Okay, we should be getting those down pretty good. And then the last one was the official one that we call the power rule. It was the derivative with respect to x of k times x to the nth. So what happens when you're finding the derivative with respect to x of k times x to the nth? We came up with that it was k times n times x to the n minus 1. Okay? All right, those are the 4 basic rules, but I'm using a different notation. This is actually Leibniz's, not Newton's notation. Leibniz, that's Gottfried Wilhelm Leibniz. He was the guy that found calculus at the same exact time that Newton did. And it was his notation that persisted throughout time that we still use today. So it's pretty cool. Imagine thinking of something and then people like 400 years later are still using it. I know, this is kind of cool. I like that. All right, well, here's what we're going to try to accomplish today. We're going to add to this list. So if you see this notation, what does that mean I'm trying to find? Or what does that notation mean? It means that I'm trying to find the derivative of the sine function. Okay? So every function has a derivative, and that derivative is another function. And that function tells you what the slope of the line tangent to the original function is at any x value. Okay, so I just so happen to have the sine wave on here. And so you see the sine wave, and then you see the green dot. Okay, the green dot at any given moment is the slope of the line tangent to the sine. Okay, so let's clarify that by just pausing here a second. So let's put this about, I don't know, about right here. So I'm going to put a dot here. So the 0.8, the negative 0.8, that's the x value. And the sine of negative 0.8 radians is negative 0.717. Okay? So the question is, what is the slope of the line that is tangent to the sine at that x value? That's the question. What is the slope of that line? Well, I see it's positive. That's one thing I know. And this green dot, once I press on this green dot, it will be revealed. So as soon as I press that, then you'll know what the slope is. At the moment when I press it.
You need like a drum roll?
Okay, so the slope of the purple line is 0.697. And this is how we say it. The language is important. The derivative of the sine of x at an x value of negative 0.8 is 0.697. The derivative of the sine of x at negative 0.8 is 0.697. Now, there's a lot going on here. I want you to just stare at this thing. So notice we're identifying every single possible slope for every single x value as we go from left to right. And if we could connect the dots of all of the green ones, it would form a new function. And that new function would be the derivative. So, and is the derivative the cosine? Look at that graph. Let's see. Do you know of a graph that when x is 0, the value is 1? And then when the x value, when we're at pi, it's negative 1? Okay, so on. And sure enough, the derivative of the sine of x function is the cosine of x function. That's funky. Okay, every single one of those values. So we just added a one to our list. Okay, so let's go change the function. What about the cosine? Now I've graphed the cosine. So the question that is out there right now is, what is the derivative of the cosine? So we're going to say number 6, the derivative with respect to x of the cosine of x. Can you figure it out by looking at the picture? Is it the sine of x? If I could connect the dots, I actually try to do that. There. Is that the sine wave?
Sure.
Look closely. It's the negative sine of x. Okay? Because you know the sine of x goes up, not down, right off the bat. And so it's actually the negative sine of x. Okay? If I plot the derivative, there it is. And oh, we're right on the money there. No problems there. Okay. So we add those two to our bank of derivative rules that we're going to come across and use later on. Okay. Picture this. You know that whole packet that we did beginning here? All the different functions? We have to know now the derivatives of all of those functions and modifications and composites of them and additions and subtractions of them. So I can make a function that's the natural log of the square root of the tangent of x, and then we can find the derivative of it. That's the ultimate goal. Find the derivative and integrate. Yeah. Yeah. What happens is the function itself, the derivative itself, does not have values either at that point. And that's because the cosine is continuous, and therefore the negative sine is also continuous. But the tangent, when we draw the tangent, it's not continuous. The function itself, let's do it as long as we're here. Okay. See, I try to follow the natural theory of learning, which is if someone asks a question, then we go ahead and do it. Okay? All right, follow the green dot. And we're going to add this to our list. Derivative of the tangent of x. We're going to have to learn it anyway. Okay, can you make some observations? Tell me something about the green dot. If they look like parabolas, don't they? Is it always above? Does it ever go below? Look at the slopes of all of the tangent parts. Is it ever negative? No. So that means that's how we know that the derivative is always positive. Okay? So, and this, if I draw it, you'll never see a negative slope. They're always positive. That's just fun to look at. Okay, so the slopes are always positive. And, all right, so here's the derivative. Okay, for every single x value, the green dot on the green curve represents it. Okay? Well, it turns out that it is not a parabola. Get in there, you bugger. It's the secant squared. Obviously. Okay. So the derivative of the tangent is the secant squared of x. Again, whatever function that you have, you can find the derivative of it. And what I'm trying to point out in answering that question is the secant squared is not defined either at any of the places where there's a vertical tangent. So it's like handled automatically within it. formula because it's the formula that gives you the slope, and if you can't find the slope, then there is no value on the derivative. Okay, to the backboard. So, number one, we're going to do a couple of different types of directions today. The first one here is find the derivative of the function at the given value of x. Okay? Okay. So we're going to break this down. I want you to think about it. In order to answer this question, we want to find the derivative of the function at the given x value. What do you think our first step should be? Find the derivative. Okay? So in this case, we're going to say find. That's the very first thing. Because we can't find the derivative value till we get it. Okay, go do this. So we're going to write f prime of x. And then go find that based upon what we did yesterday. And let's see if we got it right. So using the power rule, this is negative 2x plus 4. That's the derivative. Okay? That was step one. What should we do next? Plug in 6. Okay? So we're going to plug in x equals 6. So again, this is the notation. We're going to say f prime of 6 equals. This is the notation that you have to do it this way. Negative 2 times 6 plus 4, and that's negative 12 plus 4. I got an answer of negative 8. So here's how I want to show you. 3 dots mean therefore. Okay, 3 dots mean therefore. So to summarize what we did, therefore, f prime of 6 is equal to negative 8. That wraps up and concludes our statement. 3 dots. No ID. There. It should be there 3, not there 4. Sorry.
That's a B slap.
I just made that up. Okay, let's see how we are. Larry. Okay. Now, I like to do things with multiple perspectives, so we just did that. That's the algebraic part. Now look at this picture. Hello, Swivl. I'm going to go all year long with this.
You should count how many times.
Uncountable. Okay, notice the function. That's the function that we just did. Okay. What is the derivative of the function when x equals 6? Well, I put us at x equals 6 right here. And when I press on the green dot, we get our answer. And there it is, negative 8. The slope of that purple line is negative 8. And that's what this just did. See it? Calculus and graphs are kind of weird because It's almost like it's a secret hidden language within the graphs. Anybody can look at the graphs, but it's only the trained eye that can tell what it is that you're looking at. All right, let's do another one. I know. I know. It's the eye doctor. Yeah. I'm on a roll. Okay. All right, same directions, different function. Do the steps stay the same? All right, so here we go. G prime of x is equal to the derivative of the sine of x is cosine of x. So you just write it like this then. See? The derivative of that is this. Okay. Okay, what's the derivative of 4 over x? I'm going to do this on the side here. So the derivative of 4 over x, yeah, as it stands, that's a bad way to put it. So I'm going to write it as 4 times x to the negative 1. Because now that fits the power rule. 4 times x to the negative 1. I'm getting a couple funny looks. You get that? 1 over x is the same as x to the negative 1. Okay, so this is 4 times negative 1 times x to the negative 1 minus 1. When in doubt, write it out. Negative 4 times x to the negative 2. And then write it with a positive exponent. Negative 4 over x squared. So the derivative of 4 over x is minus 4 over x squared. Okay. So the derivative of g is g prime, and so we have this brand new function. Okay. This function is derived from that one. Okay, and then we just plug it in. So g prime of pi over 3 equals the cosine of pi over 3 minus the 4 over pi over 3 squared. Okay. And then we work it out. Okay, cosine of pi over 3. Half. So that's a half. This one, we got to make sure we know how to clean something like this up. This one, this is how I would do it. I'd say, okay, this is pi squared over 9, because you square the top and you square the bottom. And then I'd multiply both the top and the bottom by 9. So I get 1/2 minus 36 over pi squared. Okay, that's just a little algebra. How do you get from here to here? Now, warning. On the EP exam, half the test is multiple choice. Okay? It's possible that, okay, you do the work and you get your answer that looks like this. Okay? But you look on the answer of all the choices and it's not there. Because what they have is this. And you're like, well, two of those don't look like each other at all. Okay? But they're actually equivalent. What did I do? Got a common denominator. So look at this one. I multiplied by pi squared over pi squared. This one I multiplied by 2 over 2. So I get pi squared. So the inner step that you would write here is pi squared over 2 pi squared minus 36 times 2 over 2 pi squared. They have the same denominator, so that means you can subtract their numerators, and it's pi squared minus 72 over 2 pi squared. You have to know how to do the forwards and the back between anything like that. And you get a lot of good practice because when you write when you do your homework, you'll get an answer like this. But then randomly at times you'll see answers like this in the back of the book. And you'll be like, okay, how do I know that that answer is right? Well, do the math in between. Okay? So be aware that you gotta watch out for that. Okay, we got that skill down, finding the derivative at a point. Well, now we're going to do another type of problem with different directions. The directions now are write the equation of the line tangent to the function at the given x. Oh, and yeah, at the given x value. So we're just kind of extending what we just did. And so the first one we're going to do 2 minus 3, 1. 2 minus 3, 1 is this. 2x squared minus 3x plus 1 all over x. This is my function. And we're going to find it when x equals a half. So this time we're writing the equation of the line tangent to the curve to the function when x equals a half. Okay. So think of the steps. Step 1. Not only are we finding the slope now, well, we're actually, like on the picture on the front, we're writing the equation of the purple line. That's the goal. So what are we going to do first? Still, we're find the derivative. Okay? So that's going to help. So we're going to say find the derivative. Okay, so let's do this. Ooh, this one's weird. Do we have a rule for this? We got 7 rules so far. See that? Does that thing fit any of those? No, the problem is there's a function on the top and there's a function on the bottom. This is called a rational function. Okay? We're doing division of 2 functions. Okay, so we don't have that yet. But if you're clever, you can see that we can actually rewrite this. Look at 2x squared divided by x minus 3x divided by x plus 1 over x. You see that? As long as we can take each of the terms on the top and divide it by the x. And watch what happens. We can clean this up a little bit more. 2x squared over x, 2x, minus 3x over x, minus 3, plus, can't do much with that. Have we found the derivative yet? No. This is still f of x. Okay? All right, so what is the derivative, f prime of x? Go find that out. Okay, derivative of 2x is 2. The derivative of minus 3 is 0. What's the derivative of 1 over x? You better have gotten negative 1 over x squared. Do you get that? Derivative of 1 over x is negative 1x over 1x squared. Okay. So that means the derivative is 2 minus 1 over x squared. Okay. Step 1. Step 2. What is the derivative good for? Finding the slope. Okay, so let's find the slope. So we're going to say plug in the 6 or plug in the 1/2. So step 2, what is f prime of a half? What's 2 minus 1 over 1/2 squared? It's 2 minus 1 over 1/4, which is 2 minus 4, which is negative 2. There 3, f prime. I'm going to start saying that from now on. Instead of there 4, it's there 3. So that means the slope of the line tangent to that function when x equals 1/2 is negative 2. Okay, so far so good. Back to the original, we got to write the equation of the line. What else do we need? Say it again. I need a y-coordinate, right? So we need to find f of 1/2. That we need the y-coordinate for the function. So what is f of 1/2? Okay, here we go. 2 times a half squared minus 3 times a half plus 1 all over a half. Notice that we're going back to the original function to find the point. All right, what do we got to do here? You're expected to be able to do this kind of arithmetic on the test. 1 is minus 3/2 plus 1 over half. This is a half minus a 3/2 plus 1 over 2. I got 0 over 2. A 1/2 plus a 1, that's 1 1/2 minus 3/2. Oh, that would make a difference. But it doesn't change the answer. You get 0? No? 1/2 minus 3/2 is minus 2/2 plus 1 over half. So, therefore, the coordinates of the point, we can say it like this: f of a half is equal to 0, which means the coordinates are 1/2 kind of 0. That's the point that's on the graph. All right, what's the final step? We got slope. We got a point. Now we can find the equation. So, final step in the problem, write equation of line. So, I know how to do that. Y minus y sub 1 equals m times x minus x sub 1. And then I plug in the point and I plug in the slope. Okay, so my point is 1/2 0. Y minus 1/2. Y minus 0. Thank you. Keeping you on your toes there. What's my slope? -2. See, the derivative. -2 times x minus 1/2. Okay. Clean the whole bugger up. Y equals -2x, distributing here, plus 1. This is the equation of the line that's tangent to that wacky function when x equals 1/2. You believe me? Sure. Always trust me. So let's do it. Get rid of all this junk. New function. Let's do t of x equals, what is this, 2x squared? And you can do this on your calculator. You don't have to use decimals. Okay? Ooh, look at that function. Okay? That's what that graph looks like right here. Let me zoom out. See that? Kind of this funky parabola. So, when x equals 1/2, so I'm going to zoom in here. Okay, look at that. 0.50, where is that over there? That's right here. The value of the function at 0.5 is 0. And then finally, y equals -2x plus 1. What was the goal? We were set out to find the equation of a line tangent to this wacky function at x equals 1/2, and it took those 4 steps to do it. Nothing you can't do. Actually, everything besides from the derivative, that's stuff you did in Algebra 1. Find the equation of the line with this slope and with this point. Well, that's a piece of cake. It's just the old derivative is the only thing you haven't done. Good? Okay. One last piece of information, and is this. So you should be able to do that for any function and any point. Last directions. Find the x values where the function has horizontal tangent lines. Where does the function have horizontal tangent lines? let's do x cubed plus x. So the function is x to the third plus x. Okay, so stop and think. Where would this function, x cubed plus x, have horizontal tangent lines? Stop and think. Horizontal tangent lines. For example, here, the green graph has a horizontal tangent line right at whatever this x value is. That's an example of a horizontal tangent line. How can you be given any function and then figure out where it has a horizontal tangent line? She says where the derivative is equal to 0. What's the derivative at this point, x value right here? It's 0. It's wherever the slope is equal to 0, which means it's wherever the derivative is equal to 0. So, for your step here, what do you want to do? You want to find f prime and then set f prime equal to 0 and then solve. And those will be your answers. Set the derivative equal to 0 and solve. Okay, so let's do it. So this one is f prime of x is equal to 3x squared plus 1. I'm going to change the original problem. Because those of you who already see this, it doesn't have one. Which, if this was the problem, you'd say, it does not have any x values. Okay. All right, so watch this. Then we set this equal to 0. I found the derivative and set it equal to 0, and then we solve for x. So this becomes 1/3 equals x squared. And then when we take the square root of it, we get two numbers. Because we're solving the equation, it's plus or minus the square root of 1/3. You can simplify it if you want to. But this one has two places where it has horizontal tangent lines. And we're going to run out of time, but we could just graph them and show that at those two places, that's what the value is. Okay. This assignment is due on Monday. Okay? Due on Monday. This is still the second assignment. Yeah. We're still on the second assignment. Due on Monday. Test tomorrow.